Hey guys, problem number 11 from the homework. Alright, starts off with where does f have critical numbers? Remember, f has critical numbers where f prime equals 0. Or where f prime doesn't exist. F prime does not exist. Alright, so if I look at this graph of f, make sure I know what I'm looking at here. I can look for any place where the derivative equals 0, which would be like a, not like, but which would be a horizontal tangent. That's supposed to say horizontal tangent. Or any place where the derivative does not exist, which would be like a sharp point, or something like that, or a cusp. Alright, so on this graph of f, does it have any place where f prime equals 0 or does not exist? Yes, it does. Horizontal tangent, horizontal tangent. Alright, so we have two critical numbers. One would be at x equals, that's supposed to be equals, -1, and the other would be at x equals 2. Cool. Alright, part B says, on what intervals is f prime negative? So let's relate that back to the graph. When f prime is negative, what is f doing? F is decreasing. So where's f decreasing on our graph? It looks like it's decreasing on that interval and this interval. Cool. So my answer would be, we're decreasing from, let's just say, I don't know, it doesn't give us a domain here, so let's just say negative infinity to -1. It's supposed to be negative. And decreasing again from 2 to infinity. Alright. On what intervals is f prime increasing? Alright, and again we're given a graph of f, so when f prime is increasing, what is f doing? And we should say f is concave up. So where is f concave up? Looks like it's concave up. Then it switches probably somewhere about there, in between the two, the relative min and the relative max is going to be our inflection point. Let's say that inflection point is at x equals 0.5. So then our answer would be we're concave up, f is concave up from negative infinity to 0.5. So therefore that's the interval where f prime is increasing. Alright, and lastly, where does f prime achieve its maximum value? Alright, well that place is going to be where the graph of f changes from concave up to concave down. And we talked about that in another problem where our slopes are increasing here. Okay, let me rephrase that. Our slope is negative there. Our slope is 0 here, and our slope is positive here. So the slopes of our tangent lines the slopes of our tangent lines were increasing. There you go. Because you had a negative, a 0, and a positive. So our slopes went from being negative numbers to 0 to being positive numbers. So our slopes were increasing. And then they start to decrease. Yeah, they're still positive. And then they become 0. And now our slopes of our tangent lines are negative. So positive to 0 to negative. So the place where f prime achieves its maximum value would be that inflection point. I guess the easiest way to think of it is where we change from concave up to concave down. So, and that's because that's where f prime goes from increasing to decreasing. See our f prime was negative there, f prime was 0 here, and f prime was positive there. So our f prime was increasing on this interval, and then on this interval, f prime goes from positive to 0 to negative. So f prime is decreasing on that second, the red interval there. So where does it achieve its maximum? That would be our inflection point. And that inflection point would be at x equals 0.5. And we're supposed to estimate that value of f prime. So it's a graph of f, so f prime would be its slope there. So let's just guesstimate at the slope of that tangent line. Let's go with 2. Maybe it's 2. F prime is approximately 2. Alright, that's it.